The first penetration testing section in this course is going to be the network penetration testing. The reason why I chose to start with this because most of the systems and the computers that you're going to try to gain access to will be connected to a network. Whether it's a device, a computer, a phone, simply any device connected to the internet is actually connected to a network. Therefore, you need to learn how networks interact with how devices interact with each other in the network, how networks work, so that you can advance into the future into different types of penetration testing. So first of all, before we start learning penetration testing, we're going to learn how networks work and how devices interact with each other. After that, the course is going to be divided into 4 main sections. The first section is the pre-connection attacks, and the second section is gaining access. Both of these sections are mostly geared towards wireless networks. The reason behind this is usually with a wireless network, there is protection, there is encryption, so you need to use a key in order to connect to the network. So there is web, WPA and WPA2 encryptions that we're going to learn how to break. And we're also going to see what attacks you can do without having to connect to any network. So if I only had a wireless card, what attacks can I do using that wireless card? The reason why the first 2 sections don't talk about wired networks, because if you wanted to gain access to a wired network, simply all you have to do is connect your Ethernet cable to that network. Now, some wired networks use security and some of them use MAC filtering. We're going to talk about that, and changing the MAC is going to be very easy, and you're going to learn it in the first 2 sections. So if you had a wired network, you probably can jump to section 3. If you had a wireless, then you need to go through steps 1 to gain your access, and then you're at section 3. In section 3 is where the fun starts. You're going to learn how to sniff packets from the network, how to control the connections, how to sniff passwords, usernames, cookies, how to inject them into your browser, how to launch attacks that will allow you to gain full access to any device that's in your network, whether it's wired or wireless, and without the person having to do anything who's using that device. So section 3 will apply for both wired and wireless, and it works exactly the same. There is no need for change of configuration. In the last section, we're going to talk about how to secure yourself against all of these attacks and how to detect them. Before we can start trying to hack into networks and break into them, there's a few basics that we need to learn before we can do that. So basically, what is a network? A network is just a number of devices connected together. They are connected together for a reason, so that they can share data. This data can be files, can be resources. It can be, for example, your home network. Usually you use it to just access the internet, which is, you can look at it as a resource or as a source of data. So all networks, Wi-Fi or wired, achieve this sharing of data using the same principle. And that principle is, you need a device that acts as a server, and then all devices communicate with the server. So the server has access to the resource, and all the other devices on the network that are connected to this server, obviously, they can access the data from the server. So on most Wi-Fi networks, the server is the router, and all devices connect to this router, and they access the internet through the router. So all the devices on the network have no access to the internet, as we can see in this diagram. The only device in the network that is connected to the internet is the Wi-Fi router. All the other devices, as we can see here, we have client 1 and 2 and 3, they have no access to the internet, but they can access it by connecting to the router. So whenever client 3, for example, if it wants to open google.com, it's going to send a request to the router asking it, okay, I need google.com. The router is going to go to the internet. It's going to grab google.com and then forward it back to client number 3. So client number 3 does not have direct access to the internet. It has to go through the router, and the router is going to bring the request and send the response back to client number 3. Now all of this data, requests and responses, are transferred through packets. So you can imagine all these arrows are a number of packets being sent between the clients and the router. And in Wi-Fi networks, these packets are sent into the air, so they're broadcasted. And if you're within range with these packets, then you can just sniff them, capture them, and read them, and you'll be able to see the information in there. So all this data, so whether it's usernames, passwords, videos, audio, music, chats, all of that is transferred as packets, and it's always transferred between the client and the router because the client has no access to the internet. So if you capture these packets, you'll be able to see all of this data that's transferred. You'll be able to see all these passwords, usernames, emails, videos, all that. You'll be able to capture it and read it on your device. Show you how to crack the passwords for Wi-Fi networks. Other than that, you can do everything else in the course without a wireless adapter. What I mean by a wireless adapter is a USB device that connects through USB to your computer, and it allows you to communicate with wireless networks. Now, most computers and laptops come with a built-in wireless card. The only problem is, first of all, you can't access built-in wireless cards from a virtual machine. Also, even if you can, so even if you install Kali as a main machine, the built-in wireless cards are not good for hacking because we need a powerful adapter that supports monitor mode and packet injection, and we're going to go into what each of these mean. But basically, the built-in wireless adapter does not support these modes and can't be used for hacking. That's why I recommend powerful wireless adapters. They're listed in the course requirements, and I'm going to list them in the resources of this lecture, and you can connect them to Kali like I'm going to show you right now. So I already have VirtualBox open, and you just want to click the machine that you want to connect the adapter to. We're going to go to its settings. We're going to go to ports. We're going to go to USB. And make sure that USB is enabled, and you want to pick the USB option that is used by your adapter. So it's either USB 1, 2, or 3. And for the adapter that I have, it uses USB 2. Then you want to come here to the plus sign and click on it. Now you'll see that I have a number of devices that I can attach to the Kali machine. Now I still haven't connected the adapter. So first of all, I'm just going to have a look on the available devices. Then I'm going to connect the adapter. And I'm going to list the devices again. I did that because we're assuming that I don't know the name of my adapter, because the name that you'll see here is the name of the chipset that's used inside the adapter. So it's not the brand name that you see on the adapter itself. So when I click on it now, you'll see that I have a new entry called Atheros, and this is actually my wireless adapter. It's an Alpha AWS 036NHA. So I'm going to click on it. That's it added here. I'm going to click on OK. And that's the adapter added to Kali. Now, before we can start Kali, we have to install VirtualBox extensions to allow VirtualBox to use this USB device. Now, the download link will be included in the resources. I have the page already opened in here. And you can see in here, we have a link for VirtualBox extension pack, and you can just click on this link to download it. Now, this will only work for VirtualBox 5.1.22. If you have a different version, so to get your version, you can just go to VirtualBox, About VirtualBox. If you're on Windows, you'll have to go to File, About VirtualBox, and you'll see that I'm on 5.0.20. So I'll have to come back here, and I don't have the latest version, so I'm gonna have to go down to the VirtualBox older builds, go on 5.0, and look for 5.0.20 and download its extension pack. So if you have the latest version that's listed on the main page, then download it from there. If you have an older version, go to the old builds like I did, scroll down and download the one that is compatible with your version. Now once it's downloaded, you'll be able to find it in your downloads or to whatever location you downloaded it to. And then you can just double click it to install it. So this is the one that's compatible with my VirtualBox. I'm gonna double click it. And as you can see, for me, it's telling me that it's already installed. For you, it's just gonna give you an install button. For me, it's called reinstall. So I'm just gonna reinstall it just to show you how it's gonna go. And we'll need to scroll down and agree. Put your password. And that's it. The extension pack is installed. So I'm gonna hit enter. Now before starting my virtual machine, I'm gonna physically disconnect my wireless adapter, and then I'm gonna connect the adapter once Kali fully loads. Now I'm gonna start it. So I'm gonna put my username, which is root, and my password, which is TOOR. Okay, now Kali is fully loaded. I'm gonna go and physically connect my wireless adapter. And like I said, I usually do this just to avoid any conflicts. Now once the adapter is connected, you want to make sure that it's attached to Kali. And to do that, we're going to go to the devices menu. So we're going to go all the way to the top. We're going to go to devices. We're going to go on USB. And we're going to make sure that this adapter right here is checked. Now sometimes it might not be checked for you, so click on it to check it. For me, it's already checked, so I'm not going to click it. And to confirm that the adapter is connected, we can just go on terminal right here and type ifconfig. This command lists all the interfaces that's connected to the machine. And as you can see now, it's showing an adapter called LAN 0, which is the wireless adapter. So if you have this in here, that means your adapter is connected. If you don't, then ask in the discussions and I'll help you through this. Some adapters are not compatible with Kali, so that could be the issue, or the issue could be something else. Also, now if we go here on the top right, you'll see that I have a Wi-Fi option, which I can use to connect to Wi-Fi networks. Now we don't need to do this because I showed you how to set up a NAT network, and Kali already has internet access through this NAT network. So we only need the wireless adapter to hack into other networks to crack their passwords. MAC address. Each network card, whether it's Wi-Fi card or wired card, it has a physical static address assigned by the card manufacturer called the MAC address. Media access control. This MAC address is actually written on your card and it's physical, so it never changes. For your card, for your specific card, for example, for your Wi-Fi card, it will never change. It will always be the same. The MAC address is used between devices to identify each other and to transfer packets in the right direction. This works by each packet has a source MAC and a destination MAC, and it travels from the source MAC to the destination MAC. Now, because the MAC address is static and it never changes, it can be used to trace you back and to identify your device. Also, since devices use MAC address to identify each other, so for example, you'll have some networks that only allow certain MAC addresses to connect to the network. They use a whitelist. Or they can use a blacklist and blacklist your MAC address so that you cannot connect to that network. So changing your MAC address can help you either connect to the network by changing your MAC address to one that's in a whitelist, or it could let you bypass blacklists. So as I said, it's physical and static, so the only way to change the MAC address is to change it in the RAM. So it will only be changed for this session. Once you restart your device, you have to change it again. So to do this, it's very simple. We're going to use a tool called MAC Changer. So let's see how we do that. So first of all, to get your Wi-Fi card name, just type in iwconfig and it will show all wireless cards you have. So here ETH0 has no wireless extensions, and same with LO. And we can see that LAN 0 is my wireless card. So I'm just gonna disable the wireless card. So if config LAN 0 down, that's to disable the wireless card. Now we're going to change the MAC address. We're gonna use a tool called MAC changer. So always with these tools, it's always a good idea to look at the help. So if you just go on MAC changer, help, we'll see all the options that we can use with this tool. So you can use help and version to show the version, and help, show to show your current MAC address, E, so that it doesn't change the vendor bytes, it doesn't change the manufacturer of the MAC address. So another is just to try a random vendor MAC of the same kind. A is just to set a random vendor here, the capital A. P will reset to the original permanent MAC address. So if you change your MAC address and you want to use the old one, you can use P. Or will just give you a random MAC address, and L will just print the non-vendors that you can use. And M, actually, it'll help you pick your own MAC address. So you can, if there is a whitelist, and I'll show you how you can see all connected devices. So if your target network, you can see there's, for example, 3 devices connected, and this network only allows these 3 devices connect. So you can just take one of those MAC addresses and change it and use it yourself, and then try to connect, and it will allow you to connect. So let's see how we change the MAC address. We're going to use MAC changer again, and I'm just going to use random to set up a random MAC address, and then we'll put the device name, which is LAN 0. So very simple, MAC changer random LAN 0. You can use the M to specify your own MAC address if you want. So I'm going to hit enter, and as you can see, my original one was this, and it's been changed to 98A4B095CA3. Okay, so now our wireless card is ready and we've changed its MAC address. Now we need to enable it again because we disabled it by typing ifconfig LAN 0 down. So we'll do the opposite. We're going to do ifconfig LAN 0 up. And that's it. The card is enabled and its MAC address has been changed. Let's just have a look on it. If you type in ifconfig LAN 0, now we can see the new MAC address showing up in here. Now we know that the MAC address is used to make sure that the packet goes into the right direction. So each packet has a source MAC and a destination MAC, and it flows from the source MAC to the destination MAC, from the device that has the source MAC to the device that has the destination MAC. This is how wireless cards work in the default mode. So if I come in now to my Kali machine and I do iwconfig, you'll see that I have my wireless card right here called LAN 0, and you can see that the default mode is called managed mode. So basically in this mode, my wireless device will only receive packets, or will only try to capture packets that have my device's MAC address as the destination MAC. So it will only capture packets that are actually directed to my computer. What we want to do though, we want to be able to capture any packet that's around us, any packet that is within our range. So to do that, we're going to use a mode called monitor mode. This tells the wireless card is, I want you to capture everything around you, even if the destination MAC is not your MAC, I want you to capture it. So basically we'll be able to capture all the packets within our range, even if the packet isn't directed to our device. There is more than one method to enable monitor mode. We're going to talk about 3 methods. We're going to start with the basic method in this lecture, and then I'm going to show you 2 more methods. The reason why I'm going to show you more than one method is sometimes monitor mode will be enabled, but when you actually come in to run an attack, the attack will not work. So in the future, if I run some attack and you see that you're getting different results, then just come back and try to enable mode in a different way. So we're going to talk about the first method now, and we're going to use ermon-ng to do it. So the first thing, let's just run the command on its own. So we're just going to type in ermon-ng. And you can see it lists the wireless cards available. And you can see that I have a wireless card called LAN 0. So I'm going to start monitor mode on this interface. And the command is going to be ermon-ng start LAN 0. So it's very simple. ermon-ng is the name of the program, start to start monitor mode, and LAN0 is the wireless card name, so it's the interface. I'm gonna hit enter. And as you can see now, it's telling me that monitor mode is enabled on mon0. So now whenever I want to use monitor mode, I'm gonna specify mon0 as the interface, and you'll see that in the future lectures. So for you, maybe you'll probably not get the same name. So for you, it'll probably be called LAN0 mon or something else. It doesn't matter. Just make sure you use the name which monitor mode is enabled on in the future instead of mon0 for me. So if I do iwconfig mon0, you'll see that the mode now is monitor mode instead of managed, and that means that we can use this card now to capture any packet within our range, even if the packet is not directed to our device, even if it doesn't have the MAC address of our device as the destination MAC. Now I'd like to note a few things. First of all, when you enable monitor mode, the card will lose its connection. So if it was connected to a wireless network, it'll actually get disconnected. This is normal because, as I said, the card will not be in managed mode and it'll be capturing all the packets that's available to it instead of only capturing the packets that are directed to it. Also, it doesn't really matter because when we enable monitor mode, we'd want to actually hack into a different network or capture packets from networks that we don't have their password. So it's completely normal to lose your internet connection when you're in monitor mode. The next thing is, make sure that you use the name that monitor mode gets enabled on. As I said, for me it was mon0. For you it could be called something else. So just make sure you actually use the name that ermon-ng tell you monitor mode got enabled on. As I said, it'll probably be called LAN0 mon or something else. The third note is, if you enabled monitor mode and in the future you run an attack and you got different results than me, you got unexpected results, then just come back and try one of the other methods that I'm going to explain in the next lectures. Now, if you want to stop monitor mode, you can just do ermon-ng, stop, and then you put the wireless card name which is in monitor mode. Again, for me it's mon0, for you it could be something else. And that's it. Now monitor mode is disabled and we can use LAN0 in managed mode to connect to networks and use it normally the same way that you usually use it. With the latest update of aircrack-ng, ermon-ng stopped working for some of wireless cards. So it will work for some cards, but for others it will not work. It will actually say that it enabled monitor mode on LAN0 mon. So instead of just mon0, it's going to start calling them LAN0 mon. And when you try to use this card, sometimes it's not going to work in monitor mode, even though your card supports monitor mode. So for now, I actually, with Kali 2 and with the new update, I recommend using a different method of enabling monitor mode. Now this method is actually the manual method of enabling monitor mode. So my wireless card is actually LAN0. So let's just have a look on it. So it's iwconfig LAN0. This is my wireless card, and as you can see now it's in managed mode. So what I'm gonna do is I'm gonna enable it using the manual method. So I'm gonna do ifconfig LAN0 down, same way that we did in the previous method, and now the card is disabled. Now the next command is the command that's going to enable monitor mode on the card. So it's just gonna be iwconfig LAN0, the name of the card, and then I'm gonna say mode monitor. So it's very simple. iwconfig is the command, LAN0 is the name of my wireless card, and I'm telling it to enable monitor mode on this card. So I'm going to hit enter, and that's done. Now, if you don't see any error messages, that means the commands are running successfully. So now I'm going to enable the card again. So I'm going to do ifconfig LAN0 up, and that's going to bring my card up. And if I do iwconfig LAN0, as you can see now the card is in monitor mode. So in the next videos I've actually used the old method of enabling monitor mode. So I've used ermon-ng, and I'll be using mon0 as my card in monitor mode. But if you use this method, then LAN0 is the one that's going to be in monitor mode. So when I'm going to be running aerodump-ng, I'm going to use LAN0 instead of mon0 because monitor mode is enabled on LAN0 now. So as you can see now, the card works perfectly and monitor mode is enabled on it. Now you have the freedom of choosing any method you want, but this method will work on all cards, whereas the aircrack or the airmon-ng method, the method that's seen in the previous video, will only work on some cards. So we've seen two methods to enable monitor mode, and I'm going to explain a third method. Now all these methods achieve the same object, which is enable on monitor mode on your wireless card. The reason why I'm explaining so many methods is because which method work for you depend on your operating system, on your host operating system, and on the compatibility of the wireless card with both of these systems. For me, all three methods work fine. But some people, they have the first method work for them, for some people the second or the third. Now in many cases, all of the methods will enable monitor mode on your card, but not all of the attacks will work. So sometimes maybe the injection will not work, or maybe creating a fake access point will fail. All of these things, we're going to explain them in the future, so don't worry about them. But basically, what the idea to take from here is, if you know your card supports injection, if it's an alpha card like the 036H or the 036NHA, or one of the known cards that support injection, if you Google the name of your card and injection isn't working for you, or the card isn't working well for you, then all you have to do is just unplug the card, plug it back in, and try another method of enable on monitor mode. So far you have two methods, and I'm going to explain a third method to enable monitor mode. Now, if any of the methods above work well for you, then stick with it. If they don't, then try this method to enable monitor mode. So I have my wireless card now connected. And as you can see here, it's called LAN 0, and it's my Atheros card. So what I'm going to do is I'm going to disable the card just as usual. So it's ifconfig LAN 0 down. And what I'm going to do now, I'm going to run a command to kill any service that might interfere with enable and monitor mode. So the command is airmon-ng check kill. And there is no G here. And as you can see, it killed two processes right now that Airmon think might interfere with enable and monitor mode. So what I'm going to do now is enable monitor mode the same way that we did in the first method. So it's going to be airmon-ng start LAN 0. Now, as you can see, monitor mode has been started on LAN 0 mon, which is a virtual wireless interface. So I'm gonna do ifconfig. And as you can see, the mode is monitor. Now, as I said, all the three methods achieve the same goal. All of them enable monitor mode. And in the future, we're going to use this monitor mode in doing different attacks. So if the attack doesn't work for you, all you have to do is unplug your card, plug it back in, try another method of enabling monitor mode. And hopefully one of them will work well for you and you can carry out the attacks. Okay, so now we have our Wi-Fi card in monitor mode. We can sniff all the packets that are within our Wi-Fi range, even though they're not directed to our device, and even without connecting to any network, even without knowing the password or username to the network. So what tool we're going to use? We're going to use a tool called aerodump-ng. It's part of the aircrack suite. It's a packet sniffer, allows us to capture all the packets around us. We can run it against all the networks around us, so we'll collect any packet that are within our Wi-Fi range, or we can run it against a certain AP or access point, so we'll only be collecting packets that are coming from a certain Wi-Fi network. We'll see how we run the program first. First, you need your Wi-Fi card in monitor mode. I have it now in monitor mode, and the name of the Wi-Fi card in monitor mode, it's WLAN 0. So we'll just clear this, and we will run aerodump ng and mon0. It's just as simple as that. Mon0 is the name of the Wi-Fi card that has monitor mode enabled on it. And now you can see it's starting to list all the networks around us.
Another use of AeroDump-ng is to identify all the networks around us and to identify all the connected devices to these networks. So I'm just gonna Control C now to stop sniffing, and we'll just have a quick look now. All the packets that we sniffed now, we didn't save them anywhere, so there was really no point of analyzing the packets, because we just ran it against all the access points around us to see what networks are around us and what they and gather information about these networks. So you can see like there is quite a good bit of networks around me. The BSS ID is the MAC address for the access point. So each as we said, each network device has a MAC address, and it's here written under the BSS ID column. The PWR is the power, so it's how far is the access point from our Wi-Fi card. You can see the test IP. This is the AP. This is the test router that we will be running a few attacks against. It's here in my room, so it's very close to me. It's -34. You can see as you go down, the networks are further and further away from me. So the closest the network, the easier for you to get to sniff the packets, because obviously you're closer and the packets can be collected easier. Also, all the attacks that we're gonna explain in the future, the closer the network to you, the more effective the attack, and the quicker you will gain your access or achieve your goal. Beacons is the signals that the AP send. So each access point send a certain type of packets to tell all the clients around it that I exist and I'm there. So even if the network was hidden, it will still send these beacons to tell everyone around that network is, I'm here, I'm an AP, I have my BSS ID to be this, and I'm running on this information. So this is the number of beacons that each access point is sending. The data is the number of useful packets that we have sniffed. We'll talk about this later when we start talking about decrypting web encryption. So we'll just leave this for now. S is the number of data packets that we have collected in the past 10 seconds. So as you can see, we have 0 here, so 0 data packets in the past 10 seconds. Channel is the number of channel that the access point is broadcasting on. So each access point broadcasts on a certain channel. This is used so that there is no interference between access points that are beside each other. So say for example, I have an access point here, and like 5 meters from me there is another access point. If both of them are running on the same channel, there will be interference between those two access points, and the signal between them will be shorter, so the range of those access points will be shorter. So we use different channels so that there is no interference between the packets that are sent in the air. MB is the maximum speed supported by this access point, so it can go up to 54. Inc is the encryption that's used in that access point. So we see the encryption here is WIP, here is WPA2, here is WIP again, we have WPA here, and if it's an open network you'll see OPN here in the encryption. Cipher is the cipher that's used to decrypt the packets. So for WIP it's WIP, but for WPA2 it can be CCMP, it could be TKIP. We'll talk about these later when we get into WPA cracking. Auth is the type of authentication that's required for this access point. So we have PSK, pre-shared key here. We have MGT for this one, and we'll talk about this later as well when we go to WPA cracking. In the previous video, we saw how we can use AeroDump-ng to see all the networks that are within our Wi-Fi range and collect information about these networks, such as the BSS ID, the channel, the distance between us and that access point, the encryption that it uses, and so on. Now after we do that, we'll see a certain network that we want to target, or a number of networks that we want to target. So once we have our target, it's more useful to run AeroDump-ng on that network only, instead of running it on all the networks around us. So in this video we'll see how we can do that. So I have my output here from just running arrow dump ng10 on all networks around me, and I'm going to target this network. So that's my home network, the UPC62. I'm going to start sniffing on that network only instead of sniffing on all networks around me. To do this, we're going to use the same program, so it's arrow dump ng, and then we're going to specify the channel. So I'm going to give the channel, and the channel here is number 2, as you can see here. And then I'm going to specify the BSS ID, which is the MAC address of the target network, and it's this. So we're going to copy paste it. And then I'm going to add a write option, and this tells arrow dump ng to log all the packets that it captures into a file. And the file name is, I'm going to call it now, so let's call it test UPC. And then we put the name of our Wi-Fi card with monitor mode, and it's mon0. So arrow dump ng, same as the program that we used before. Channel, we put the channel of the target access point, and BSS ID, we put the MAC address of the target point, access point, and write, we put the file name that we want all the packets to be stored on. And then we have mon0, the name of our Wi-Fi card with monitor mode. So I'm going to hit enter, and as you can see, the only network that shows up is UPC62. We don't have any other networks with us. And we can now have a look on this section. In the previous video, we had too many networks here, so we only had one section in arrow dump ng. This section was missing here, the second section. So the first section, as we saw in the previous video, contains all the access points that are within our Wi-Fi range. This section here. Now the second section contains all the clients that are associated with the access points here. So in here, this is not a network, this is a client, and it's connected to this network. We know that because we see the BSS ID here. That's the MAC address of the network that this client is connected to. So the MAC address here is the same as the MAC address here. So that means this client is connected to this network. Now the station is the MAC address of the client. So this is the MAC address of the device that is connected to the network. Power is the distance between us and this device. Rate is the maximum speed that this device is running on. Lost is the number of packets that we lost, we couldn't capture from the target device. And frames is the number of useful packets that we collected from that device. We'll talk more about frames and data, as I said, when we start talking about web cracking. So just want to show you now the two main parts again. So the first main part is the access points that are within our Wi-Fi range. The second main part of arrow dump is the clients that are associated with these access points. We have the MAC address of the access point here and the MAC address of the actual client in here. Now I'm going to Control C. So now all the data has been logged into a file called test UPC. I'm going to use ls, which is a command to list files in Linux, and just list the files that arrow dump created. So it's going to add a star after it. And we see arrow dump automatically created four file formats. So in our command, we only specified the file name as test UPC. You can see that arrow dump automatically added a 01 to the file name. It adds this just in case there is another file that has the same name. And then we have 4 different file formats: the cap, CSV, Kismet, and Kismet XML. Let's go have a look on the files here in my home directory. So it should be called test. Yeah, that's it. So that's the files here, and they're in the home directory because my terminal is working in the home directory. If we go pwd, we see we're in the root directory. Okay, now we can, after we sniff those packets, we can use a program such as Wireshark to analyze these packets and see what information we gathered. The problem is, in this specific network, it's using WPA encryption, so all the packets are encrypted, and we won't be able to decrypt them unless we have the key. So we're going to talk about how we crack the key in section 2 of this course. For now, let's just and we're going to talk about how we use Wireshark in section 3 of this course. So I'm just going to run Wireshark just to give you a quick look on how the packets show up. So they're not going to be useful, they're all going to be encrypted, so they won't really be any use to us. So if I'm going to go on the open file and test, yeah, that's the file name, and I opened it, and we see here we can get some information. So we can see, for example, here the source device is a Broadcom device, and it's going to it's just being broadcasted here. We can see here we have an Apple device communicating with the Broadcom. That's as much as you'll get. You'll get MAC addresses, you'll get maybe devices, manufacturers, very simple information. All this because the network is encrypted. We're going to talk about how we can decrypt it and how we can get very sensitive information after we connect to the network. If it's an open network, you can connect to it straight away and jump to part 3, where we're going to talk about these powerful attacks. For now, I just wanted to give you a quick look on how the packets look when the network is encrypted. Don't be scared of Wireshark. We're going to talk about it again in the 3rd section. We're going to explain everything about it. So for now, I just wanted to show you a quick look on what the packets look like. The authentication attacks. So we're still in our 1st section of the course, which means all the attacks that we're going to talk about are attacks that we can launch on any network that is within our Wi-Fi range, even if the network has encryption, even if it uses a key, and even if we don't have that key. So we don't have to connect to any network to launch these attacks. The deauthentication attack is very useful. It allows us to disconnect any device from any network that is within our Wi-Fi range. To do this, we're going to spoof our MAC address to the target client MAC address. So the target client is the client that we want to disconnect. We're going to pretend to be him, and we're going to send a deauthentication packet to the router. So we're going to tell the router, I want to disconnect from you. At the same time, we're going to spoof our MAC address to the access point MAC address, to the router's MAC address, and tell the target client, the client that we want to disconnect, we're going to tell him, you need to re-authenticate yourself. So when we do this, we're going to successfully disconnect the target client. So we're going to pretend to be the target client and tell the access point that we need to disconnect from you, we want to disconnect from you, and then we're going to pretend to be the access point and tell the client, you need to reconnect, if you need to re-authenticate yourself. When we do that, the connection is lost. We're going to use a tool called AirPlayNG to do it. So let's see how we can do that. First of all, we're going to need to run AeroDumpNG on the target network, because we want to see which clients are connected to it. So we want to see what devices are connected to this network. So our first command is going to be AeroDumpNG, and I'm not going to need the right option, so I'm just going to delete it here. So all I'm going to need is AeroDumpNG channel. We put the channel of the target network, and BSSID, the MAC address of the target network, and we hit enter, and now we're sniffing on my target network, which is UPC62. So my target device is going to be this device. This method would work on any device, whether it's a Linux, Windows, Mac, if it's a phone, Android, iOS, it doesn't matter. They all use the same method of transferring packets, so it's going to work on any Wi-Fi enabled device. Let's make sure we have connection here. I'm just going to go to google.com, make sure I'm connected to the internet. Okay, so we see now that Google is working perfectly. Let's go back here, and I'm gonna split the screen here. So we're gonna run AirPlayNG now to disassociate one of the devices from the network. We can run it to disassociate all devices, but I found when I do that, it doesn't really disassociate all of them because we have too many targets to disassociate. So I'm gonna choose one target, which is going to be this device, the device that we just saw. So it's going to be AirPlay NG, and then we're gonna deauthentication attack, and then we're gonna put the number of deauthentication packets that we're going to send. So I just put a very large number to keep the device disconnected. Then we're gonna put the target access point. So it's the MAC address of our target access point. This is it. And then we're gonna put the source or the client MAC address. That's the device that we want to disconnect, and it's this device here. So I put its MAC address there, and I'm just gonna put 10 my Wi-Fi card with monitor mode. So again, AirPlay NG, deauth, the number of packets. Then we put the MAC address of the target AP, and then the MAC address of the device that we want to disconnect. Gonna hit enter, and AirPlay NG now send in the authentication packets. Let's go to the target device and see if we still have internet connection. And as you can see, we lost our connection, and it's now trying to reconnect. It's not going to be able to reconnect because we're still sending the authentication packets. So this device is successfully disconnected, and we can launch this attack on any network that we want without we don't need to know the username, we don't need to know the password or the key to that network. Creating a fake access point. A fake access point is basically an access point that just looks normal to any user, and it doesn't have encryption on it, so people can connect to it without having to enter a key. It's an open network, and it should have internet connection to attract people to use it. So why would we create a fake access point? Well, if we create a fake access point, we're going to attract a large number of people to connect to this network and access the internet. Once they do that, they're going to be doing login to usernames, logging in to their accounts, and doing what they want to do on the internet. Because the access point doesn't use encryption, so we'll be able to sniff it very easily and sniff and capture all the information that they log. Creating an access point is simple. It just needs to be set up correctly so that the access point can function correctly. Now the first thing we're gonna need, two cards. So one card is gonna be connected to the internet. It doesn't matter what card is it. It could be a 3G card, it could be a wired card, it could be a wireless card. All we need is a card that is connected to the internet. And then we're gonna need a second card, and that card has to be a Wi-Fi card. So this second Wi-Fi card is gonna be used as the access point. It's gonna be used to broadcast the signal of the access point. So this is our hacker device. We're gonna need two cards connected to our device. One card that is connected to the internet, and the other card is gonna act as an access point. It's gonna broadcast to tell all the devices around it that I'm an access point and you can connect to me and access the internet. So how are we gonna do this, or how it's gonna work? Say for example, client number 1 wants to access google.com. So it's gonna ask our Wi-Fi card to get that, because our Wi-Fi card is pretending to be the access point. Now the Wi-Fi card doesn't have internet connection, so we're gonna have to set it up in a way that once it gets a request, it goes and it talks to the second card that is connected to the internet. Now the second card is gonna go bring the request, forward it back through our device to the Wi-Fi card and back to client number 1. Let's do this again. So we have two cards, one of them connected to the internet. Let's say it's a wired card. That's what I'm going to use in my example. and the second one is a Wi-Fi card that's going to act as the access point, and it's going to broadcast the signal. So devices are going to connect to this device, to the Wi-Fi card. They're going to ask for google.com. The Wi-Fi card is, we're going to set up our device in a way that once it gets a request, it goes and it asks the wired card that has internet connection. The wired card is going to go, it's going to bring google.com, and it will bring it back to the Wi-Fi card. The Wi-Fi card will forward the packets back to client number one. That's the theory part of how a fake access point is going to work. In the next video, we're going to do it in a practical way. We'll see the commands that we're going to need to use, and it's going to become more clear once you actually do it and once I explain all the commands to you. Okay, now we're going to talk about a tool called Mana Toolkit. Mana Toolkit is a tool that allows us to create fake access points. The tool is very easy to use, and it automatically creates the fake access point for us instead of us manually typing the commands to create the access point. The tool also has a few scripts that allow us to run a number of other tools to allow us to sniff the traffic that happens in this fake access point, bypass HTTPS, and even attempt to bypass HSTS. So the tool comes in with three main scripts. The first one is start no upstream. Basically, this script will create a fake access point, but this access point will not have internet connection. So when someone connects to this fake access point, they will not be able to connect to the internet. The other one, the start not simple, is my favorite one, which basically creates an access point, a fake access point with internet connection. So when someone connects to this access point, they will be able to access the internet, and all the packets will be flowing through our device because we are the router, or we are the access point. So we'll be able to analyze these packets, capture them, and read them. The third one is the start not full. Will basically create an access point with internet connection, and it will also automatically start sniffing, so recording the packets that are flowing through this fake access point, and it will attempt to bypass HTTPS and HSTS. Now, I'm not going to be using the third one because a lot of the time this actually fails. And in the third section of this course, where we're going to talk about the attacks that you can do after connecting to the network, we're going to learn how to bypass all these things and how to sniff packets, capture them, read them, and analyze them. So for today's lesson, we're only going to use the start not simple, where we're going to create an access point with internet connection. And in the future, we're going to see how we can actually capture these packets and analyze them. So before I do anything, I just want to show you the settings for the Kali machine. So I just want to make sure that you use a NAT network as well. So if we go to settings, to network, and make sure that you're using a NAT network. So this is exactly what I showed you in the previous lecture. Now make sure that you have Mana installed, and to install it, all you have to do is run apt-get install Mana Toolkit. Now I already have it installed, that's why it's telling me that it's already installed and it's the newest version. Now I'm going to clear this. Now right here, if we do ifconfig, you'll see that we have an interface called ETH0, and this interface is actually created used by VirtualBox by the NAT network. So it's a virtual interface that is connected to the NAT network, and it's supplying internet connection to this machine. So at the moment, I don't have a wireless card connected to this machine. And so if I do iwconfig, you'll see that I don't have a wireless card. And this machine has internet connection coming from the virtual network made by VirtualBox from ETH0. So if I try to ping google.com, you'll see I'm getting responses back from Google, which means that this particular machine have internet connection. Now you can go to Firefox and try to browse something, and Firefox will work. So I'm getting my internet connection from the virtual interface made by VirtualBox. You can get your internet connection from anywhere you want. So if you have two wireless cards, you can use two wireless cards. If you have an Ethernet cable, you can get it from the Ethernet cable. In this case, I'm getting it from ETH0, the interface with the IP address
the one that is connected to the internet. Now, what I'm going to do is I'm going to connect my wireless card now to the Kali machine, and I'm going to go to the devices, USB, and pick my card. Now the card should show up when I run iwconfig. So the card is only used to broadcast the signal. It's not used to provide the internet connection. The internet connection is coming from the ETH0 from the virtual interface made by VirtualBox. So I'm going to do iwconfig. And as you can see now, I have a new card called LAN0. This card is in managed mode and it's not connected to any network. Okay, so what we're going to do now, we're going to set up Mana's configuration and start the fake access point. So the first thing we're going to do is modify the host apd mana file, which is located in etc mana toolkit host apd mana.conf. And I used leafpad because this is the editor that I want to modify the file with. So leafpad is just the name of the program, and then we put the location where the file is located. So right here you can modify the settings of the fake access point that we're going to use. The most important thing is the interface that we're going to use to broadcast the signal. And for me, it was called LAN0. Remember when we run iwconfig, this is my wireless card. This is your wireless card that's going to broadcast the signal, and it's not connected to anything, and it's called LAN0. Now you can modify the MAC address or the name of the network. So the name of the network in my case is going to be called internet, and the channel is going to be set to 6. So I'm actually not going to modify anything. I just wanted to show it to you in case your wireless card was called something else other than LAN0. In most cases, it will be called LAN0. Now, the other file that we want to modify is the startnet simple, and this is the file that will launch the access point. So again, we're going to use leafpad. And in here, again, the first thing that you want to make sure that you set it correctly is the PHY. And this will be, again, your wireless card. So my wireless card was called LAN0. If yours was called something else, then put it in here. And the next thing, the upstream, this is very important as well. You should specify the card that has internet connection. This is the card that's supplying internet connection to the machine. For, in my case, it was called ETH0, the virtual card made by VirtualBox, and it was the one that had IP address. Again, everything is set up correctly here, so I'm not going to modify anything. I'm going to keep everything the same. I'm going to close it. And my last step is going to be running Mana, and it's going to be running the startnet simple. Instead of saying leafpad, we're going to say bash to execute this file. So our command is going to be bash user share mana toolkit run mana startnet simple.sh, and I'm going to hit enter. Now this happens sometimes. So the best thing to do, or the best thing that I noticed, is you literally just run it again and it should work the second time. Okay, so the access point is running now. And what I'm going to do, I'm going to go to my Windows machine and try to connect from it. Now, I'm going to use another wireless card for the Windows machine because the Windows machine is going to be a virtual machine as well. So I'm going to be using a second wireless card connected to the Windows machine to try and test this network. In your case, you can try to connect from your phone or from another laptop. Do not connect from your host machine because you will not have internet connection, because the host machine is the one providing the internet connection for everything. So you either test it from your phone, from a separate laptop, or you can test it from your virtual Windows machine, but make sure you use another wireless card with that machine. So we're going to go back to our Windows device and we're going to search for networks to connect to. And as you can see, we have an extra network now called internet. And as you can see that it has no password. So we're going to try to connect to this network.
and we managed to successfully connect to this network. And I'm gonna go to my browser and see if I have internet connection. So I'm gonna go on bing.com. And as you can see that we actually have internet connection, and through this fake access point, and that all the packets now are flowing through this device, because this is the AP, this is like the router, so all the packets will be flowing through this device. Now we can actually use Wireshark or any other tool or TCP dump or T-Shark to capture the packets and analyze them. Now again, I'm not going to be talking about that right now, because we're going to explain it in details in section 3 of this course.
So far, everything we've done, we didn't need to connect to any network to do it. The good thing about connecting to a network is you'll be able to launch more powerful attacks and get more accurate info when you connect to it. Now, if the network doesn't use encryption, if it's an open wireless network, then you can go ahead and connect to it, and then you're at section 3, you can sniff unencrypted data. If the network is a wired network, then you can connect to it using your wire, or you can try, after you connect to it with the wire, maybe you need to change your MAC address to something else so that you can connect. The main problem is if the network uses encryption, such as WEP, WPA, or WPA2. We've seen if we try to sniff the data will be encrypted. And if we want to decrypt it, then we need to know the key. And if we know the key, then we can just connect and the data will be unencrypted anyway. So that's the main purpose of this section of the course, is if your target network uses some sort of encryption, and you can't really do anything more now unless you decrypt or find the key so that you can decrypt the data and connect to the network. So we're going to talk about how to decrypt WEP, WPA, and WPA encryptions.
The first encryption that we're going to talk about breaking it is going to be WEP encryption, because it's the oldest one, it's the easiest one to break, but we still need to learn how to break it because you will see networks that still use WEP encryption. WEP encryption uses an algorithm called RC4. Each packet is encrypted at the access point and then it's sent to the air. Once the client receives it, since the client has the key, it will be able to decrypt the packet and read the information inside it. So very simple. The IP encrypts the packet, send it, client receive it, the client has the key, so the client decrypts it. Same way when the client sends the packet, it encrypt it, and then send it in the air. The access point receive it, the access point has the key, so it will decrypt the packet. So each packet that is sent into the air has a unique key stream. WEP ensures that the key stream is unique by using a 24-bit initialization vector. So the initialization vector is a random number. It's sent into each packet and it's sent into plain text. So this part, it's not encrypted. If you read the packet, you'll be able to read it in plain text. The problem with the IV, or the initialization vector, it's very short. 24 bits is not that long. So in a busy network, there'll be a very large number of packets sent into the air. This means the number of possibilities of random IVs will be exhausted, and we will have two packets that have the same initialization vector. So the initialization vector is a 24-bit random key. It's sent into the air in each packet, and it's sent into plain text as a plain text. In a busy network, we're going to have a very large number of packets. This means that the possibilities of unique IVs will be exhausted, and if we are sniffing all these packets, we will be able to collect two packets that have the same initialization vector. Once we have two packets that have the same initialization vector, aircrack-ng can be used. It will use statistical attacks to determine the key stream, and after that it will be able to determine the WEP key. Okay, so from the above we know the more IVs or initialization vectors that we collect, the more likely that we'll successfully crack the WEP key. So our main goal now, when we try to crack web, is to collect as much IVs as we can, because once we have a large number of IVs, and we're gonna have two packets that use the same IV, then aircrack-ng is more likely to be able to determine the key stream and the web key for the target network. In the next video we'll do that. We'll see how that actually works, and it should be easier to understand. Okay, so from the previous video we know that to crack a web key, all we have to do is sniff packets from the target network and gather as much IVs as possible. Once we do that, aircrack-ng will be able to use statistical attacks to determine the key stream and then the web key. It does this because when we have a large number of IVs, as I said, the IV is only a 24-bit number, so it can be exhausted easily in a busy network. So once we have two packets that have the same IV, then we can decrypt the key stream and the web key. Now, when we have more than two packets, obviously the method is going to work better, and our chances of breaking the key will be higher. So we're going to try to gather as much IVs as possible. Let's see the most basic case of cracking web key. First of all, I have my Wi-Fi card in monitor mode. So the first thing I'm going to try to do now is just see all the networks that are within my Wi-Fi range. And then I'm going to target one of those networks. So we're going to go aerodome, ng, 10, just very basic. And the second network that came up is the network that we're going to do our attacks on. So it's a test AP. So we're just going to launch aerodome against this network now. So we're going to put the BSS ID like we did before. Just launch an aerodome against this AP. And then I'm going to put the channel, number 2. And then I'm going to add a write to store all the packets that we capture into a file. And let's call it basic test AP. And that's it. So aerodome ng, BSS ID, MAC address, channel, and the file that we're gonna write stuff to, and our Wi-Fi card in monitor mode. Just launch an aerodome on a target network. Now, as you can see, this target network that I have here is quite a busy one. You can see the data and the frames it's going up quickly. Well, quick enough, not very quickly, but it was very quick at the start. It is a busy network, so we have a client here. This is the section where we see the clients. So this client is actually I have it actually playing video on YouTube, so that's why it's going up quick and it slows down, quick and slows down. So we're just trying to mimic active client here. So all we have to do now is just launch aircrack, which is part of the aircrack suite, against the file that aerodome has created for us. We can launch aircrack against it even if we didn't stop aerodome, and it's gonna keep reading the file and read the new packets that aerodome is capturing here. So we're just gonna go aircrack ng, and we put the file name. So the file name was So this file is still being created. It's still getting larger and larger because it's getting more packets. But we can run aircrack ng with that file running, and then with aerodome running, and it's gonna keep getting updated, and it'll give us the password once it can crack it. So now aircrack is working, and aerodome is collecting the packets for us. As you can see, aircrack failed to determine the key within 5,000 AVs. So it's gonna, with 3,000 AVs, it's gonna wait until the AVs reach 5,000, and it's gonna try again. Now the number of AVs actually depends on the type of web. So there's two types of web encryption. There is 128 and there is a 46-bit. The only difference is the length of the key. So the 46-bit will require less number of IVs than the 128. Now the IVs, remember when we were talking about error crack, we said data is the number of useful packets. What I meant with that is the number of packets that have a unique IV or have a new IV. So the more packets we get with different IVs, the more our chances of cracking the web key. Now we're basically just gonna wait until error crack can successfully crack the web key. Okay, perfect. I'm just gonna Control C error dump now. And as you can see here, error crack successfully managed to get the key. So that's the web key for the target network. We were able to get it within 23,000 of data packets. That's because the target AP uses a 64-bit key. Let's see how we can use this key to connect to the network. So I'm just gonna copy it. I'm gonna go to Genie. And we're just gonna remove these dots and use the key like this. So now we can connect to the target network. And here we go. Let's see, test AP. And just gonna paste it here. Connect. And as you can see, our connection has been established. So we successfully recovered the key, the web key for our target network. So I can just go to and confirm, ping Google, and ping works. So we are successfully connected to the target network. So in the previous video, we saw how easy it is to crack a web key in a busy network. So we had a busy network, we had a client that was watching videos all the time, and we saw how the data was increasing very quickly. Now the question is, or the problem that we're gonna face, is an access point that doesn't have any clients connected to it, or an access point that has a client connected to it, but he's not using the internet as heavy as we saw in the previous video, maybe just reading articles or just going on Facebook or whatever, but not using as much data as we saw last time. So let me just show you an example of that. I'm just gonna run arrow dump against the target access point, the test AP, just to have a look on an idle access point. So we have test AP now, the same access point that we used before. The only difference is that I've disconnected the device that was connected. And you can see here in the second area, the clients area, that there is no clients connected. And you can see the data is 0 and didn't even go to 1. So that's going to be a problem that we're going to face. We won't be able to crack the key like this with 0 data. So what we can do is we can inject packets into the traffic. When we inject packets into the traffic, we can force the AP to create new packets with new IV in them. We capture that IV and we do that again. That's the basic case that what we're gonna do. But before we can inject packets into the air, we have to authenticate our device with the target access point. See, the way that access points work, they have a list of all the devices that are connected to them, and they ignore any packet that comes from a device that is not connected to them. So if a device that doesn't have the key tries to send a packet to your router will just ignore it. It won't even try to read it or see what's in there. So before we can inject packets to the router, we're gonna have to authenticate ourselves with the router. We're gonna use a method called fake authentication. It's very simple. We're gonna have to do it before every time we try to inject. I'm gonna explain it now, and then in the future we're just gonna run the command straight away. So I have arrow dump already running now. Let's see how we can fake authenticate ourselves. Remember when I talked about arrow dump and we reached the auth, I said this is the type of authentication, and I said I'll come back for it later. So you see now the auth there's nothing here. Once we do the fake authentication, you're gonna see an OPN showing up here, which means we've successfully fake authenticated our device with the target access point. So to do this, we're gonna use AirPlayNG. We're gonna use a fake auth attack. So we put the type of attack, and then we're gonna put the type of the number of packets that we want to send. So I'm just gonna do 0. Some people use a large number when they have when they're carrying attack that'll take like 5 or 10 minutes. But for me, I like to just use 0 and maybe do it later manually. So fake auth 0. We're gonna use the option A, the target MAC address. So I'm just gonna copy it from here, and I'll paste it. That's done. We're gonna use H to put our MAC address so that our MAC address gets authenticated with the target network. So to get our MAC address, we're just gonna run the command ifconfig LAN 0, and that's my MAC address. So I'm just gonna copy it. LAN 0 is the name of my Wi-Fi card. You can put Mon 0 because they're the same card, so they have the same MAC address. I'm gonna paste it here, and then I'll put the name of my Wi-Fi card, Mon 0. So AirPlayNG, the type of attack that we're trying to do a fake authentication attack to authenticate our MAC address so that we can inject packets into the target network. We're gonna send 0, which means do it once, and then A, we put the MAC address of the access point, and then H, we put the MAC address of the device that we want to do a fake authentication to, and that's my own wireless card. And then Mon 0, name of the Wi-Fi card, and then I'm gonna hit enter. And as you can see, it said an authentication request, and it was successful, and association is successful now. So, and you can see here in the auth, it became an open network, and our client, this is my attacking device, showed up as if it's a client connected to the network. We're actually not connected, but we are authenticated with the network, and we have associated with the network, so we can inject packets into this access point now, because it will receive any request that we send it now. It's not gonna ignore our requests. In the next videos, we're gonna see how we can inject packets into the air and how we're gonna make this data go up very, very quickly. The access point now accepts packets that we send to it because it's not going to ignore us, because we've successfully associated ourselves with it using a fake authentication attack. Now we are ready to inject packets into the access point and make the number of data increase very quickly so that we can decrypt the web key. So the first method of packet injection that we're going to talk about is ARP request replay. In this method, we're going to wait for an ARP packet, we're going to capture this packet, and we're going to inject it into the traffic. When we do that, the access point is going to be forced to create a new packet with a new IV. We're going to capture this new packet, inject it back again into the traffic to force the access point to create another packet with another IV. We're going to keep doing this until the number of data is high enough to crack the web key. Let's see how we do this in Kali Linux. So first thing I'm gonna do is just launch aerodump-ng. I'm just gonna add a write to it, and let's call it this time ARP request reply test. And that's it running, and you can see that the target network has 0 data, so it has no clients associated with it, and there's no traffic going through, so it's not useful. We can't crack its key. First thing we're gonna do is we're gonna do a fake authentication now. And as you can see, the fake authentication was successful and the auth has changed to open. So we can start injecting packets into this network and it'll accept our packets when we inject them. That's going to lead us to our third step, which is the ARP request reply step, where we will be injecting packets into the target network, forcing it to create new packets with new IVs. So the command is gonna be, just paste this now, very similar to the previous one, just instead of fake auth, we're gonna say ARP replay. I have an extra IR here, so ARP replay. Yep. Okay. And then instead of A, we're gonna have B for BSSID. So the first command here we did was just an association command, so that we can associate with the network and we can start injecting packets without being ignored. Here. The third one we're gonna do here is the command that we're gonna wait for an ARP packet, we're gonna capture it and then re-inject it in the air. Let me just associate myself again there, and I'm gonna launch this command. So, in here in the third section, replay is just waiting for an ARP packet. Okay, as you can see, we've captured an ARP packet, and now it's injecting the ARP packet here. So it captured an ARP packet, it's injecting it in the traffic. The AP is creating another packet with the new IV. We're receiving it, injecting it again, and we're just doing this over and over again. You can see the number of data has already reached 9,000. I'm just gonna launch aircrack ng now. I think by the time I launch it, I'll be able to crack it. So I'm gonna aircrack ng, same command that we ran in the basic case. Let's just see ls_star.cap and it'll show up for us. Yep, so that was it. So aircrack ng file name, and sure enough, here we see the web key, and we were able to crack it very easily. The number of data has reached 39,000 by now, so it's running up very quickly. We saw in previous videos how easy it is to crack WEP encrypted networks, even if there was no devices connected to the target network, and even if the target network was idle. We also explained a number of methods to inject packets into the traffic and cause the number of data to increase very rapidly, so that we can crack the WEP key in a very short period of time. Now in the next few tutorials we're going to talk about WPA encryption. This encryption was designed after WEP, and it was designed to address all the issues that made WEP so easy to crack. The main issue with WEP was the short initialization vector, which is sent as plain text in each packet. The short initialization vector meant that the possibilities of having a unique IV in each packet can be exhausted in active networks. So when we were injecting packets or in natural active networks, we will have more than 2 packets that have the same IV. When this happens, aircrack ng can use statistical attacks to determine the key stream and then determine the WEP key. In WPA, however, each packet is encrypted using a unique temporary key. This means that the number of data packets that we collect is irrelevant. Even if we were able to collect 1 million packets, these packets are not useful because they do not contain any information that can help us crack the WPA key. Now I'm talking about WPA, but it's the WPA2 is the same. It works by the same method, and it can be cracked using the same methods. The only difference between WPA and WPA2 is that WPA2 uses an algorithm called CCNP for encryption. So cracking WPA or WPA2 encrypted networks, it's not simple, especially that all the packets that are sent into the air are not useful for us, as they do not contain any information that can help us determine the WPA key. Before we get into cracking WPA and WPA2, there is a feature called WPS. It allows users and clients to connect to the network by a push of a button. So on Windows 8, and if you look on some Wi-Fi printers, they have a WPS button. So if you press that WPS button and you go to your router and press the WPS button there as well, or go to the configuration page and press the WPS button, the client, the printer or your Windows device will connect to the network without having to enter the key. So the purpose of using WPS, it's a feature that allows clients to connect to the network easily without having to enter the WPA key manually. So it's just a feature in routers. This feature works and authenticates the client based using an 8-digit long PIN. So it doesn't use the actual WPA key, it uses an 8-digit PIN. This is only digits and it's only 8 bits long, so there isn't too many possibilities for this, and if we use a brute force attack, we are guaranteed to guess this PIN. If we successfully guess this PIN, then we can use a tool called Reaver, which would calculate the WPA key from this PIN. So we're going to brute force the PIN, the 8-digit long PIN. Because it's only 8 digits, we're guaranteed to be able to brute force it successfully. Once we do that, we can calculate the WPA key using Reaver. Again, this is only a feature in routers. This flaw is not in WPA or WPA2 encryption. The problem is in the WPS feature. So let's see how we do this first. To look for access points that have WPS enabled, we're going to use a tool called Wash. So I'm just going to put Wash I10. So we have our test AP showing up here. That's the AP that we're going to use to crack. So this is actually running on WPA now. It's not using WIP as we saw in the previous videos. I can confirm that for you here. I'm just going to use arrow dump. This step is not important. I'm just going to use it to show you that test AP is actually using WPA encryption. It's not WEP. So as you can see here, test is using WPA encryption. Let's just go back. So these are the access points that have WPS enabled, that have the WPS feature enabled. We can see the channel, the RSSI, which is the distance between us and the access point, the WPS version, and this WPS locked. Now, some routers, when you try to brute force the WPS pin, they lock after a few failed attempts. So if you try, for example, 4 wrong pins, they're gonna lock and not accept any pins for a certain amount of time. So if the WPS locked says yes here, then you can't actually use this attack now. So you need to wait for a little bit and come back to this access point. So we're gonna launch Reaver now. Reaver is going to brute force the WPS pin, and once it's able to find the WPS pin, it's going to work out the WPA key. Reaver supports pause and resume. So if you for example brute force 30% of the possibilities and cancel the attack, if you come back, you're gonna start again from 30,000. You're not gonna start from 0. So let's launch Reaver. We're gonna put B to choose the BSS ID or the MAC address of the target access point, and then C to choose the channel, which is 11, and then I and choose the Wi-Fi card with monitor mode, and that's 10. So very simple. Reaver, access point, BSS ID, channel, and then the Wi-Fi card with monitor mode. Gonna hit enter, and now Reaver associated with the target access point. It tried to determine the WPS pin. Now I have an easy pin, which is 1234567 0, and from that it was able to calculate my WPA key. So that's the WPA key, UAU RWSXR, and that's just the name of the access point. So I can just come now and connect to my network, and if I put the key that we just found, I'm going to show the password, and it's UAU RWSXR, connect. And as you can see, we connected successfully to the network. Now there's a few options that I'd like to show you for Reaver. I'm just going to go Reaver, help. And that's all the options that you can use with Reaver. So as I said, some routers would lock after a few failed attempts. Therefore, you can use some of these advanced options to get Reaver to work against these access points. For example, you can use the delay option and specify the amount of time in seconds that Reaver should wait between each brute force attempt or each pin attempt. You can also use the lock delay to tell Reaver to wait, for example, 60 seconds after if the access points gets locked, then wait for 60 seconds and then continue your brute force attempt. You can use the fail wait as well to set the time that Reaver should wait after 10 failed attempts. You can use the OR option to tell Reaver to sleep after a certain amount, to sleep for a certain amount of seconds after a certain number of tries. You can set up the timeout. You can play with these options, the delay options, and the timeout, the fail wait, and all that if the access point was locking or was ignoring some of your brute force attempts. In the previous video, we saw how we can use the WPS feature in routers to crack the WPA key. This process is 100% guaranteed, so it should work on every WPS enabled network, and therefore if your target uses WPA or WPA2 encryption and it has WPAs enabled, then that should be the first method you try to crack the password with. If WPS was not enabled, however, we have to crack the actual WPA key. Now, we explained in previous video that in WPA, each packet is encrypted using a unique temporary key. So it's not like WEP where IVs were repeated, and once we collect a large number of data packets with the same IV, we can calculate the WEP key. In WPA, each packet is encrypted using a unique IV, and it's a temporary unique IV, so that even if we collect 1 million packets, these packets will be not useful for us because they do not contain any information that can help us determine the actual WPA key. The only packets that contain some information that can help us determine the key are the handshake packets. These are 4 packets sent when a new device or a new client connects to the target network. So for example, at your home, when your own device connects to the network, so you have the password and you connect to it, a process called a 4-way handshake happens between your device and the access point. In this process, 4 packets called the handshake packets gets transferred between those 2 devices to authenticate your device with the access point. Using AirCrackNG, we can use a word list and test each password in this word list against the handshake. So, to crack WPA encrypted networks, we need 2 things. We need to capture the handshake and a word list that contains passwords to try each password in this word list against the handshake. So to crack a WPA key, the first thing we're gonna need is to capture the handshake. We're gonna capture the handshake using AeroDump-ng, the same way that we used to use it with WEP encrypted networks. So we're gonna run AeroDump. I'm just gonna run it on everything now to get the information about my target network. And this is my target. So it's AeroDump ng BSSID, same way we used to run it against WEP networks. At the end of the day, we're only capturing packets using arrow-dump ng, so it's doing the same job. So I'm gonna put the channel as well, and then I'm gonna write to a file, and then I'm gonna call the file test handshake, and then I'm gonna put the wireless card with monitor mode. So it's the same command we used to use when we were capturing packets for WEP networks. Arrow-dump ng, BSSID, we put the target access point, channel, we put the target channel, write, we put the name of the file that we're gonna store stuff in, and 10 is our Wi-Fi card with monitor mode. Gonna hit enter, and here we go. So we have our network now. This is a WPA encrypted network, and we have here a client connected to this network. So to capture the handshake, again, we said the handshake packets get sent every time a device connects to the target access point. So now we can just sit down and wait for a device to connect to the network. Once the device connects to the network, we're gonna capture the handshake. Or we can use something that we learned in section 1, which is the deauthentication attack. In the deauthentication attack, we were able to disassociate or disconnect any device from any network that is within our Wi-Fi range. If we do that for a very short period of time, we can disassociate this device from the network for 1 second, and then the device is going to try to connect back to the network automatically, so that even the person who is using the target device is not going to notice that, but his device will actually get disconnected and reconnected so quick that he won't notice it, but we will be able to capture the handshake packets. So again, we said the handshake gets sent every time a device connects to the target network. So what we're going to do is we're going to do a deauthentication attack the same way we did it in section 1. We're going to disconnect this device from the network for a very short period of time, so that his system will reconnect him straight away without him noticing that, but we will be able to capture the handshake. So we're gonna just run a basic deauth attack using airplay ng. We explained this in section 1, and in section 1 we put a very large number of packets when we were disconnecting our target. Now I'm only gonna put a small number only for the authentication packets. Then we're gonna put the MAC address of the target access point, and then I'm gonna put C to specify the client MAC address, the MAC address of the client that we want to disconnect, and then I'm gonna put my Wi-Fi card name, which is mon0. So airplay ng deauth, the name of the attack, for the authentication packets to this access point and disconnect this device from it. Now I'm gonna hit enter. And just so I have, it's deauth, I missed a U here. And as you can see, we captured the WPA handshake here. And my target device was this. By the way, it didn't even change in here, it didn't tell me I was disconnected, because it will show a message when I get disconnected. So I didn't get any messages to be disconnected because I was disconnected for a very short period of time. And as a result, the target person didn't even notice it, and we were able to capture the handshake, as you can see here, WPA handshake, from this device. Now we can use a word list and run it against this handshake to try and determine the main WPA key. Okay, now that we've captured the handshake, all we need to do to crack the WPA key is to create a word list. A word list is just a list of words that aircrack ng is going to go through and try each one of these words against the handshake until it successfully determines the WPA key. So the better your word list is, the more your chances are of cracking the WPA key. If the password wasn't there in your word list file, you will not be able to determine the WPA key. Now I've attached a list of ready word lists that you can just download and use, or you can create your own word list using this video tutorial. We're going to use a tool called Crunch. It's basically just a script that you specify the characters that you want in the passwords, and it'll create all possible combinations of these passwords. So the format of the command of using Crunch is crunch minimum maximum. The minimum is the minimum number of characters of the password that you want to create. So you can say I want a minimum of 4, 5, 6, whatever you want. Maximum is the maximum number of characters in the passwords. Characters, you're going to specify the characters that are going to be used to create the passwords. So you can specify A, B, C, D, E, F, G, all the lower letters, and then you can write the capital letters. You can put numbers, you can put symbols. So here you'll specify the characters that you want. And then T is very useful if you know part of the password. It's a pattern. So for example, if you're trying to guess a password and you've seen someone type in this password, so you know, for example, it starts with an A and ends with a B. So you can use the pattern option and tell Crunch to create passwords that always start with A and end with B, and it'll put all possible combinations of the characters that you put in here. So for example, in this example, we have Crunch. We're going to create passwords of minimum of 6 characters and maximum of 8 characters. And the passwords are going to be combinations of the characters 1, 2, 3, 4, 5, 6. And these symbols is going to be stored in a file called word list. And the pattern is this password or that are going to be created, they're always going to start with an A and they're always going to end with B. So all the passwords that you're going to see in the file are going to always start with A and end with B, and they'll have all the possible combinations of the characters you specified here between the A and the B. So let's just run it here and create a sample word list. I'm going to say crunch. And then we're gonna make a minimum of 6 and maximum of 6, or let's say minimum of 4, maximum of 6. And just so that it doesn't take a long time, I'm gonna make it short. I'm gonna put the characters. So I'm gonna just put 1, 2, 3 AB. I'm gonna store this in sample word list. So Crunch is going to create a combination of passwords, minimum of 4 characters, maximum of 6 characters, and it's going to create all possible combinations of 1, 2, 3, AB, and it's going to store all that in a file called sample word list. Now we can read this file. We can just say cat sample word list, and we can see all the passwords that are stored in this file now. So that's all the passwords that Crunch created for us. So you can see it was 19,375 combinations possible from only 1, 2, 3 AB. Obviously, the bigger the password that you put, the more characters you put, the more passwords that you can make, and the more space they're gonna take. So let's just have a look on the pattern option. So we'll go crunch. Let's say a minimum of 5 and a maximum of 5. So all passwords, I want them to be 5 character long. And then I'll put the characters, which are 1, 2, 3, AB, like before. And then I'm going to add the T option, which is the pattern. And I'm going to say I want a password start with an A and end with a B. And I want all possible combinations of my characters between the A and the B. And then we're gonna specify the output file, and let's call it pattern word list. And you can see here it's gonna create 125 passwords, and let's have a look on them. And as you can see here, it's always starting with an A and always ending with a B. So you can use Crunch now to create your word list, and in the next video we're gonna use the word list and the handshake file to determine the actual WPA key. Now that we've captured the handshake from our target access point and we have a word list ready to use, we can use aircrack-ng to crack or determine the key for the target access point. Aircrack-ng is going to go through the word list file. It's going to combine each password with the name of our target access point to create a PMK. The PMK is created using a certain algorithm called the PBKDF2. So it's not like just combining the password and the ESS ID. It's encrypting them in a certain way. And then it's going to compare the PMK to the handshake. If the PMK was valid, then the password that was used is the password for the target access point. If it wasn't valid, then aircrack-ng is just going to try the next password. So again, aircrack-ng is going to go through the list. It's going to combine each password in the list with the name of the target access point to create a PMK. The PMK is compared with the handshake. If the PMK is valid, then that password is the password for the target access point. If it's not, then it's just going to try the next password. All this is going to be done using aircrack-ng. Let's see how we do it. So it's going to be aircrack-ng, the name of the file that contains the handshake, and that is test handshake01.cap, and then we'll put -w and the name of the word list. So I have it called WPA word list. So aircrack-ng, test the name of the file that contains the handshake, and then we have the name of the word list after the -w. I'm gonna hit enter, and now aircrack-ng is gonna go through the list. As you can see, it's trying all the passwords. It's gonna combine each password with the name of the target access point to create a PMK, and then compare the PMK to the handshake. If the PMK is valid, then the password that was used to create the PMK is the password for the target access point. If the PMK is not, then it's just going to try the next password. And as you can see, the key was found, and that's the same key that we were able to find when we attacked it using the WPS feature. So this was the basic way, using a word list, and it took 2 minutes and 16 seconds to crack the password. Now the speed depends on how quick your processor and if you have any processes running that's making your computer a bit slower.
Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to deauthenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm gonna check and get the IP of my computer or of my device, and I'm just gonna do if config lan 0. And as you can see, this is the IP of my computer. So I'm gonna open my browser, and I'm gonna navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet. At the moment it's 192.168.0, and I'm just gonna add number 1
because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a de-authentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a de-authentication attack to de-authenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using fconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 in authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now, my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control, and using this you can add policies. So you can add an allow policy or a deny policy, and using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to only to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list, and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and adding number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures.